Hello, everyone. And also, like my companies, also the title of today's presentation is maybe a bit of a mouthful. But hopefully, many of you may find the topic useful if and hopefully when you decide to make your dream ideas come true and actually publish your game someday. Most indie games don't die because the idea was bad, but they die because they can't handle their own weight. And what that means from a technical perspective, that is that the foundations of the game, they start to break down and the technical debt stalls the progress and then kills the drive. So today we are going to talk about how to stop the firefighting mode and then start building a game that actually wants to get finished. And also, as a quick side note here, even the title says that mentions the Unity and the couple of code examples there are Unity related, then all of these same principles, they do apply to the other engines as well, including if you even decide to build your own. So before we get to the actual presentation, just a few words about who I am to give you a bit of a context we're actually listening to. So hello there, my name is Jere Ranta, as was already told by Jonas, so thanks. And I'm one of those, self-learned programmers, and I've been coding like almost the day I got out of the diapers, and regardless of what vibe the future might bring, in a way or another, I'll probably be continuing coding until I'll be back in the diapers again. And I've been earning my living from programming a bit over a quarter of a century now, and 20 last years of that has been in the game industry itself. I started in a company called Digital Chocolate, my game industry journey, and you might have heard that mentioned before, as it's often quoted as the birding nest for quite a few success stories in Finland today, particularly on the mobile side. Since I left the DC, I actually left to start my own game company, and I have founded several own companies. Not much about those. Then I've been involved in multiple early phase startup companies as well, and mostly in different CTO, tech lead positions. And I also acted as a technical lead for bigger studios, like, for example, Playstack. Then in the side, I have been also teaching game programming as a freelancer, particularly Unity for about a decade now. And past few years of that has gone through my own consultancy and education company called Kindlejot. I know I should have maybe chose something a bit easier to pronounce. And as a programmer, I'm a bit of a polyglot. So I do code with whatever gets the job done. While I do love, for example, Unity and C# with, the endless libraries, the assets, whatever not, and you have everything available. Then I also spent my spare time writing my own barebone Vulkan engine from scratch, using not much anything else than just modern C++. Couple of wrapping libraries and make files and things like that, but just to stay close to the metal. When I'm not, staring at the screen all the time or the debugger, then I love to get lost on the woods or go the longer runs in streets and in trails. And why I mentioned this is because, okay, this sounds very cliche, but the production of a video game, it's more like a marathon, not a sprint. But I say this because I believe in it. It requires the same kind of discipline. You need to know your resources or maintain your pace, and then, to be honest to yourself about what are your skill levels, so you know that you can actually finish that race. And it's very much like finishing a game. Also, as a side note, while I am presenting my own company Kindlejot here today, I'll actually also be starting a couple of weeks as a lead developer in a bit bigger studio, Finnish game company, which is more known for its frustrated birds. And why I'm saying that is that I'm trying to say that the advice which I'm giving you here today, I hope it's not just some theory which I came up, but actually things which I have learned over the years and all the mistakes I've done. So maybe you wouldn't go and do those same mistakes. So let's see what I'm talking about today. So these couple of things, I try to break them down a little bit in a more practical terms. So first, we're going to take a look for the most common reason why the projects often stall after a promising good start. And then those ways how you can actually escape that trap. First thing to avoid them is how you should plan your game more like a Lego blocks, and instead of like trying to carve it from one big single monolithic stone, which often happens. And then that modular mindset, we extend the idea with data-driven programming to scriptable objects, and then enforce it even further with states and events. It's more in a theoretical level than actual examples. And then after that, we are talking about performance. And when I say performance, I don't mean like how many billions of polygons you can push per frame, but about stability, because nothing kills the immersion like a lagging frame rate. So it's all about maintaining your time financials, like I like to say them, and realizing that your code is in fact transactional. And then finally, I will be talking about the importance of tools and why building them is your ultimate cheat code when it comes to you and your team's productivity. And then in the end, I'll try to give like too long didn't watch version of it all. And after that, not during the presentation, I'll try to, with my best ability, to answer in case you have some questions. I guess they come from the chat, if I'm correct. All right, so without the further ado, let's start by figuring out why so many promising projects often end up being pushed out half finished, or even worse, not getting released at all. So usually when you are starting to work in a new project, in the beginning, when you're building that proof of concept, everything is absolutely amazing. Like you're hacking and slashing, and then you're finding the fun, and then you're seeing massive progress from day to day. And I call this the honeymoon of the prototype phase. But then when you're going forward from there, something happens. You add a double jump, and then suddenly the inventory breaks, or you fix a bug in the AI, and now the UI just disappeared. So this is called the technical suffocation. You have built your pieces from spaghetti, and now the whole noodle bridge starts to collapse. Every quick hack you have used to move so fast, that has been like a high interest loan, and now the bank is calling it in. So more than that, like it's like partying on a credit card. It is good for a while on that night, but the next morning when you wake up, then I guess you need to pay your debt. So the trap is thinking that that same code base which you initially used to find the fun would be the same one that can actually ship the title, ship the game. Unfortunately, very often that's not the case. In fact, trying to force a prototype into production is usually the leading reason why the talented teams burn out and quit in the middle of production. So production is about predictability. So if your team is spending 4 days a week just solving the bugs, and then you have only like 1 day left for building the new features, then you aren't really anymore in the developing a game. You're just full-time firefighter there. Okay, so now that we have identified the issue, how do we solve it? Well, first of all, I want to say contradict a bit. Like, there is absolutely nothing at all wrong with building the prototype from this spaghetti code. It is very fast and it does give you the much needed results early, as it should. I mean, I develop all of my prototypes as fast as I can and with as ugly code that I would never show it to anyone. But it's actually about realizing that the refactoring itself, or even rewriting everything from scratch and started again all over again, it's very natural step in the progress itself. So it is better for you to accept it early instead of trying to patch up a massive growing ball of bubblegum and duct tape. And here you see like this. Usually in the prototype, you have the tendency of building these massive God objects. So you have like one single player class, and that handles the input and the physics and the health and the video effects and sound and so on and so on and so on. So it is thousands of lines long, and you're very proud of it because it actually works and proves the fun. But then, as soon as you go with that and hit the production, the God objects are the typical reason where the projects go and die. So instead, when you're going forward to that production, then we need to think in a modular mindset. So we stop thinking about the player as one singular thing. Instead, we start thinking about it as a collection of behaviors. So this is composition over inheritance. As an example, if you have a health class that only handles health, then that should be something generic, which you should be able to put into the player class. And then you should be also able to put it on a, say, crate, or you should be able to put it in explosive barrel, whatever needs a health behavior. So those models, you should be able to write it once, test it once, and then it should work everywhere. At least in theory. I know the practice might be a bit different. And if I need to change one feature in the player, say for example the inputs, then I shouldn't be searching it all the way. Go scroll past the code for applying the gravity or playing the footstep sounds. I should be only modifying this scriptable the script itself, which is responsible for the input. And you might or might not have heard of a set of programming principles called solid. And I'm not going to bore you about with the computer science thesis today. You can study it yourself later. But from that solid, I would want you to remember at least the first letter, and it stands for S, for single responsibility principle. And that means that if a script has more than one reason to change, then it's going to be a liability. So if you're changing your UI and your player's movements breaks, then you have basically violated this principle. So by following this mindset, we're now building a steel bridge instead of the spaghetti one, which we saw earlier. So it's made of independent parts that are bolted together. And if one of these bolts then breaks, you just go and replace that bolt. You don't actually have to tear down the entire bridge, like in a prototype. And then the next most powerful tool following this modular mindset is called data-driven programming, which usually in Unity we can achieve, for example, with scriptable objects, or most often, yes. So when you are in the prototype phase, the truth of the whole thing lives inside the code itself. In the rapid prototyping phase, when you want the player to move faster, you just change the number in a script, and that's set. But once you are moving to the production itself, then the truth actually lives in the assets. So while in the prototype you're doing magic, then it's best achieved with these magic numbers. But that will start to hinder the progress when you're actually transitioning into the production itself. It starts to seriously slow down the progression when you're constantly needing to be tweaking every little constant here and there, and then going back and forth with the designer, like you were doing your code and then he asked you to change this there, and then you jump back there, and then it's forward and back. And even in the case if the programmer and the designer are the same person, so you're doing everything as a single solo developer, then you're still, those things still require like two different hats to wear, and you're constantly switching yourself gears between the coding mindset and the design mindset. So do yourself a favor and don't hesitate to move your constants, even the most obvious ones which you think you will never touch ever again, like say the force of gravity, for example, a very solid constant. Then still move it to a dedicated data container, which in Unity, as I mentioned, most commonly are in scriptable objects. So think your code as the engine and the scriptable object as the fuel. So by separating them, your designers can balance the weapon damage, the player speed, or enemy health in real time without touching a single line of your code and without actually waiting for recompile. So this isn't just a technical choice, it's a team's productivity choice. And then to wrap up our steel bridge analogy, the architecture here, we also have to talk about the predictability. So the card objects often come with a giant chain of if-else statements, because that's usually the fastest way of implementing something, and that's what you want to do in the prototype. So for example, the new double jump animation when you're already in the mid-air. But as you can imagine, very quickly, that will create some of the most noodly implementations, and you will find yourself in very quickly in this stage soup where everything is very mixed up. You're never quite sure like why the player is playing a door opening animation when the gay footstep sound is triggered, and then you're trying to track it down everywhere. So instead of attending a daily bug fest where you spend all day fixing what you broke yesterday, it is a lot better to move to the state machines, finite state machines, or the concept. When things follow their clear separate stages, such as say walking or jumping, or separate one in more broad scale, like for example loading or in-game, then your game flow becomes predictable and it is going to be a lot easier to debug. Other thing you should pay attention is the usage of events and delegates. There's going to be even more about this later, but instead of a player script telling directly to the UI script to update their health bar, which then couples them together, this is called tight coupling, by the way, the player should just broadcast that I took damage without really caring like what that may imply or who cares about it. And then any system that actually cares about this information, like UI or the sound system or the camera shaking routine, whatnot, whichever is interested of this, they just subscribe to this event and then they react accordingly. So this will make your extendability just so much faster and easier. Making sure that removing a pebble from your inventory doesn't just suddenly send a character into an infinite crouching loop for no obvious reason. So by using these modular cornerstones I just mentioned, so composition, the data-driven design, and the events, you have now built a bridge that won't collapse. But even a steel bridge has its weight limit. So let's move to the next step, the time financials of your game, the frame budget. So in the game development, the time isn't just a measurement, it is actually currency. So typically, you want your game to run at a smooth 60 frames per second, giving you exactly, roughly 16.6 milliseconds to do everything. And those of you who play first-person shooters, me included, might argue that you have even a lot less time available, as you really want to have a smooth frame rate as possible. But think about it, like in the time which is less than what it takes for you to blink your eyes, your game has to actually calculate everything. It needs to calculate the physics and determine, for example, the visibility cooling, like what's visible, and animate the characters and update the UI, and then in top of all of that, to run your code, which you have in your update methods. And now if your game spends 6 milliseconds rendering and then 4 milliseconds on physics, then you're already way over halfway of your paycheck. So then if your player logic takes now 5 milliseconds because it is a massive code object doing way too much work, then you're dangerously close to actually bankrupting your frame. And then when that frame takes 17 milliseconds instead of 16 milliseconds, then Unity will actually skip that. So the frame will be skipped and the player will feel it. It is a stutter and it's a hitch, and absolutely nothing kills the immersion faster than a lagging frame rate. So remember, your code is transactional. Every single line you write has a cost. And if you're not sure about the price, then you probably shouldn't be buying that feature. Okay, so I talk about that you should avoid things, but how do you know what does actually then steal your time? Well, you could, and you actually should also run a profiler to determine like the choke points in your code. But just to get you started, here are some of the more common culprits, which initially they might seem quite innocent, but in the long run they end up causing performance issues in rather unpredictable ways. So here we have first the GameObject.find, and that is the most expensive way to get a reference to something. It actually goes through all of the game objects in a scene to get a match, and it might initially feel or like in a closed sandbox or separate test unit scene, it might seem like it's fast enough. But then when you have that code piece, where you had that, and then it ends up in a massive large scene made of countless thousands of game objects, then it starts to have some serious impact on your time consumption without you actually even realizing. But if you are using the GameObject.find, then do it once at the start or awake, or better yet, just use reference instead. But never ever do it inside the update method. And then the next one, the get component. That one is a bit more predictable, but nevertheless bad when it is inside the update loop. So I do see quite often this, that students are putting the get component inside update loop. Even usually younger developers in company, they just put it there. But what you don't realize is you're actually asking the CPU to search the components of an object 60 times a second for something that has actually never moved, never changed. So if you're opening the same door every single time, maybe keep the key in your hand. So gauge your references. Again, get your component once in the start or awake, and then just store the result. And then next, the heap issue. So these are the issues which we get from a high-level language such as C#. Java, I don't know who is using that nowadays, but it's that usage of the garbage collector. It's great when you don't have to manually deal with your memory, but it also comes with caveat. So for every time, for example, when you're using the new keyword inside a loop, like say new list or new vector tree array, then you're metaphorically speaking just throwing trash on the floor. And eventually, when you're doing that, the janitor, or better known as the garbage collector, they have to come in and stop the entire game just to clean up your mess. And that's where those random hiccups usually come from. And then on this list, finally, I have the strings. So every time you add two strings together, like for example, the score text equals your score, and then you would add to that your current score variable, then you're actually creating a completely new object to the heap. And due to the cage misses in a long play session, that adds up as a massive performance step. Okay, and how to fight this? Well, you don't need to be an optimization wizard to actually fix this. Usually, as already mentioned earlier, it's just about changing where you put that piece of code. So, for example, instead of searching for objects with the find, then inject them instead. Either use inspector or the drag and drop them references themselves directly, or cage them in the awake, or better yet, use injection network framework. And that's goes to the memory. You should use object pooling. So don't instantiate and then destroy your bullets when you need them. Just disable them and then put them back in the box to be reused. So creation and deletion, particularly because of the garbage collector, they are very expensive. But toggling a boolean on and off, true and false, that's nearly free. And then regarding those strings, which I said earlier, say if your particular game requires building a giant block of text, for example, let's say item summary in a RPG, or a certain storyline for something, then you could use, for example, string builder, as that's designed to handle strings, without creating the garbage on the heap. They reserve the space already before in the memory. But when you're using it for simple UI, like in the previous example, then the fix is a lot easier. You probably should already know this, as I discussed it in the modular section. But the solution is just stop updating the text every single frame. So if the player score is, for example, 100, then it will most likely stay as 100 until the player actually gains more score. So you shouldn't be running a string concatenation on every single frame. Just only update the UI when the data actually changes. So use events. And in fact, this applies to anything which is in the update method itself. So again, instead of checking, for example, is the player dead yet every single frame, as mentioned earlier in the modular section, then use events instead. So player should yell, I died once, and then the UI should react only that once time. So I would say that the golden rule, what comes to the performance engineering, is that the fastest code is the code that has to never run at all. So to summarize, if it doesn't need to happen 60 times per second, then just don't put it in the update at all. And okay, then there's the profiler. Like I said earlier, you could and you should use the profiler. And yeah, sorry, I know the profiler that might look a bit intimidating. Like there's a lot of moving parts and ticks and things, and it's kind of tempting to just ignore it. But here's the secret: just don't look at the whole thing as one whole graph. Just look for the spikes. That's where the issue is. So if you see one giant vertical line, or better, even like you see in this example screenshot, there is just it directly said that the frame exceeded the 16.6 millisecond time, then just click it. And then the profiler will tell you exactly which script and which line of the code just bankrupted your frame. So it is the only way to move from guessing to knowing. So 90% of the time, the actual professional optimization, it's not about being a math genius or figuring out the most clever algorithm to save some time, but it is about being a responsible accountant. So if you respect this 16.6 millisecond budget, your game will feel solid, professional, and most importantly, shippable. And then finally, let's talk about the ultimate cheat code in the game production, the building your tools. When you're getting in speed to develop your project, you often think that, I don't have time to write the editor scripts. I have a game to finish. But usually the professional developer thinks the polar opposite of this. Like, I don't have time not to write the tools. So think about their designer. If they have to play through 5 minutes of the level just to, test, for example, the boss fight, then they are potentially wasting hours of their life every single week on absolutely nothing. But in other hand, if you are spending 20 minutes of writing a teleport to boss button in the inspector, then you just get that time back to the project and you can get forward that much faster. So the math is actually quite pretty simple. So maybe initially it might seem like spending half an hour on something which can be done in just a few minutes is just not worth doing it. Then quite quickly anyway, those few minutes starts to accumulate. The return of investment per minute spent compared to the minute gain, you start to very quickly heavily favor writing the tool for it. Starts to seem that it makes sense. So the tools are also force multipliers. Like, there are scripts that check if all your textures are in the right size, or buttons that set up an entire enemy prefab with one click. So they also prevent the technical suffocation by making the boring, repetitive tasks disappear and removing some of the human error. Or you could also think about, your future self as the most important teammate. So if you build a tool today that saves you 10 minutes, then you aren't just saving time there, but you're actually saving your own sanity 3 months from now when you're tired and stressed and, trying to hit that milestone. Besides, with the rise of AI guided programming, seems to be the hot topic nowadays, is the cost of writing these tools. It is nowadays dropped to almost zero. Like, there's very little excuse not to make those tools, since they remove the obstacles both from you and then your team's creativity. Remember, once you move to production, the development isn't anymore just about writing the best code, but it is about making sure that your team can work without being blocked by your code. So build the machine that builds the game, and you will cross the finish line while others are still manually fixing their prefabs. And well, then it's time for me to actually contradict everything I just said. So after all, I told you about the solid principles and the modular mindset and the steel bridges and all of that. There is another new trap. It's the over engineering. So it's a true story. I've actually seen brilliant seasoned developers spending literally years of redesigning and refactoring everything over and over and over again, and then never managing to get to the next steps in the development. So this is just as dangerous as the spaghetti code. So it's just different kind of technical suffocation. But how to know what is too much? Well, you could use, for example, the Kajaani principle. So it stands for you ain't gonna need it. So you shouldn't add up functionality unless it's actually needed by the specification of your game. So, for example, say that you shouldn't build a generic modular, highly abstracted, event-driven damage system if your game actually has only one enemy type and one weapon. Then maybe just hack it. So, how to know when you need it, when not? Well, you could, for example, use this rule of three. So, the first time you need it, then just write it quick and dirty way. And if you need it again the second time, then just copy it and alter if it's needed. But if you need it third time, then that's a sign for you that it's time to maybe rethink and refactor it into a more modular system. So your game's architecture, it's more like a bridge. So it needs to be strong enough to carry the things which it's intended to be used by. So the purpose of your code is to deliver the game it's made for, nothing more. If you're spending all of your time, making stronger bolts or heavier beams or lay even like more solid concrete foundation for a bridge, then you will actually never cross that river in the end. So despite all what I told earlier about your goal, it's not going to be about writing the best code ever, but your end goal is actually ship a great game. So find the golden middle ground and be pragmatic. So use just enough of structure to keep you fast, but not too much so that you're getting stuck in the mud of your own complexity, and not so little that you're just keeping fixing the bugs instead of making the game. Okay, right. So if you fell asleep or got distracted by bug of your own project during this talk, then like I promised, here's the too long didn't watch version of it all and a summary wrap up. So first, respect the transition. So hacking is great for prototypes, but it is a high interest loan paid back before it suffocates your project. Then build with modularity. Use composition and the single responsibility principle, so that your scripts don't need to depend on things which don't belong to them. Or in fact, better yet, actually go and learn all that solid principle itself and adapt it to your workflow. You'll thank me later if you do that. And then think your game as an engine fueled by data. The fuel should not be added in the factory or inside your engine, and neither should your data be written directly into the code, but rather as an asset which you add later. So use scriptable objects to get out of the way of your designers. And then stay on your budget. If you have 16.6 milliseconds in your dispose, then don't waste it on things which you actually don't need. And use the profile to catch these time criminals. And then finally, build tools. Be the developer who makes the whole team faster, not just the one who writes the most brilliant algorithm. So if you're going to follow these principles, then you're not just making a game, you're actually going to finish one. And then that would be all of that, but a couple of quick non-technical tips before we end here, and I see if you have any questions. So first, code for the humans. So computers, they don't care if your code is messy, but your teammates do, and you do as well. So write code that is easy to read, not just clever. Someone needs to read that later. And then second, don't get too attached. So If a feature it's not working or the architecture is slowing you down, then kill it. Don't let that bad code to drag you down. And then third, stay curious. So in the 25 years ago when I started, I wasn't using Unity. There wasn't Unity. And as it seems, as you can probably read every single day on the news, in the next 5 years, it might be that I'm not even going to be typing my code anymore. It's just rather instructing something on what I want, and then it creates the code for me. But the specific tools, they do change, but the principles behind the logic or performance and the architecture, they remain. So just never stop learning. And then as a very final thing, remember that shipping is a skill which you can practice with repeating. So ship games. The best code base in the world is worth absolutely nothing at all if it never sees the day of the light. So be pragmatic, be disciplined, and cross that finish line. So thank you.